This is part 2 of the homework video guide on combining exponent laws, and we will start off with question 7a. And for question 7a, I need to write each expression in simplest form without brackets. So these are very good combination questions here. So when you have these combination questions, sometimes it's good to start with the expression inside the brackets. So here are my brackets right here highlighted in blue. So you might want to start inside the brackets here. So I have the variable d to the 5 times d to the 4. So that's the same thing as d to the power of 9 divided by d to the power of 3. And then I have my coefficients of 2 and 4 there. And all of this is being raised to the power of 3. Okay, and then we'll continue attacking the inside the brackets, because I have d to the 9 divided by d to the power 3. So if the bases are the same and if we're dividing, we just subtract the powers. So if I have my 9 and my 3, 9 minus 3 is going to be d to the power of 6. And then if I take a look at my coefficients here, 2 divided by 4, 2 divided by 4 is really 1/2. Alright, so we have 1/2 d to the power 6. And if I want, I can rewrite this as d to the power of 6 divided by 2. And then the 3 is on the outside there. Okay, so now finally the last thing I have to do is now I need to deal with this outside 3 there, so I can distribute that into the brackets. So if I multiply that out, 6 times 3 is going to be 18, so d to the power of 18 divided by, and then finally I have the 2 here, and 2 is being raised to the power of 3, so 2 to the power of 3, which is equal to 8. So my final answer is d to the power of 18 divided by 8. Okay, so that's the final answer for question number 7a. So these are all good questions here, so let's keep on doing a few more of these combination questions. So just like the previous question, we want to attack the inside expression, the expression inside the brackets. That's where we probably want to start. So I have a -16, I have an 8, and there's also a 2 there, right? So it might be good to kind of look at this -16 and this 8. So if I divide -16 by 8, I get -2. Then if I take this -2 and if I multiply that by that 2, I get a 4. So the coefficient I have is a 4. Sorry, and then there's this negative sign there, right? So -4 there. So if I look at all the numbers there, I simply get -4 if I multiply the numbers and divide. Okay, so that's it for the numbers there. All right, now let's take a look at the variables now. I have a to the power 5 and a to the power 2. So a to the power 5 and a to the power 2 is a to the power 7. And then I have an a on the bottom, so we're dividing by an a, right? So 7 minus 1 is 6, so this will be a to the 6. Okay. After that, let's take a look at my b variables. I have a b cubed, a b to the 6. So b cubed and b to the 6 is really b to the power of 9. And then I divide that by b to the power 7, which is really b to the power 2, right? So now I have b to the power 2. All right, so that's how you simplify the inside expression, right? You multiply the numbers with the numbers, divide the numbers with the numbers, and then you multiply the variables and divide the same common variables. And now this is being raised to the power of 3. Okay, so that's what I mean by attacking the inside first. And now we can go backwards now. Let me get a different marker here. 3 times 2 is 6, so I have b to the power of 6. And then 3 times 6 is 18, so a to the power of 18. And then I have this -4 and this 3, right? So that's really going to be bracket -4 to the power of 3. Okay, so now we need to simplify this expression here. So think about this coefficient, -4 to the power 3. That's -4 times -4 times -4, which is -64. And then the a to the power of 18 and b to the power 6, that's what remains. Okay, good. Let's keep on going now. Let's look at question 7c here. So another good question here. So let's go ahead and attack the expressions inside the brackets first. So if I take a look at my first bracket here, the only thing that I can see that I can simplify are the variables here, right? So look at all these k variables. So if you think about this in your head here, 3 plus 2 is 5, so that's k to the 5. and then you're dividing by this single k there, right? So k to the 5 divided by k to the power 1 is really k to the power of 4. And then you also have this negative 5 here, right? So this negative 5 will tag along as negative 5. And then you have your k to the power of 4, right? And all of that is inside the brackets, and that's being raised to this power of 2 there. Okay, so that's the first bracket there. Okay, let's take a look at the k's, the k variables in the second set of brackets there. So you want to be very careful here. So just from experience here, negative 5 to the power k, that's really like, that's the same thing as negative k times negative k times negative k times negative k times negative k, which is really negative k to the power of 5, times k to the power 2, which is negative k to the 7, divided by k squared, which is really negative k to the power of 5. Okay, so if I go ahead and start the next set of brackets there, I have this negative k to the 5, and then that's going to be divided by this single 5 down there. Okay, so a little bit of work to do in terms of simplifying the expressions inside the brackets, and it's very important that you're doing all the previous homework questions, because question number 7 is really combining all the questions that you've seen so far. Okay, let's keep on going here. I have a negative sign and a negative sign, so when I multiply two negative expressions, I get a positive number there. So this, actually no, let's just, sorry, I made a mistake there. Let's just go ahead and go backwards here now. So I forgot there was a 2 there, so I multiply that out. 4 times 2 is k to the 8. And then I have this negative 5 here, so it's really negative 5 to the power of 2. And then over here I have the bracket negative 5, negative k to the 5, all divided by 5. Okay, now let's keep on going here. Let's take a look at this negative 5 to the power of 2. So that's negative 5 times negative 5, which is positive 25 k to the 8 times negative k to the 5 divided by 5. All right, so this is a great question because there's a lot going on in this particular problem here. Now I have 25 divided by 5. 25 divided by 5 is a 5. And then I have k to the 8 times negative k to the 5, so that's going to be a negative answer there. And 8 plus 5 is going to be 13, so k to the 13 there. So I get negative 5k to the 13 once that question's all done there. So question number 7 is a great, the questions in part 7 are pretty good because there are a lot of multi-step questions there where you need to know all the concepts in order to kind of move through with these problems there. Okay, let's keep on going here. Let's go to question number 8. So a combo question here. So there's an invisible 1 there. So if I look at the numerator there, let's go ahead and simplify the numerator. So 6 plus 1 is 7. Divided by 6 to the power 4, and if we're subtracting, if we're dividing, we subtract the powers, so 7 minus 4, and that's going to be 6 to the power of 3. And that's it. We're not going to evaluate that because that's a very big number, but 6 to the power of 3 is a fair answer there. Okay, another great question here where we have a negative sign inside the brackets, and there's a 2 there, so I would just do this question by writing as a repeated multiplication because there's a negative sign in the brackets, and once you write this as a repeated multiplication, you can see that we have 2 negative signs. So if I multiply 2 negative expressions together, I get a positive answer. And then 3 to the power 3 times 3 to the power 3 is really 3 to the power of 3 plus 3, which is just positive 3 to the power 6. And positive 3 to the power 6 is the same thing, it's just 3 to the power of 6. Okay, let's move on. Next question here, let's go ahead and tack the brackets first. So if I tack the brackets first, if we're dividing, we subtract the powers, so 10 minus 5, all to the power of 3, and 10 minus 5 is going to be 5. And then now we just kind of use the power to power rule there. We multiply that out and we get 2 to the power of 15. Great. Let's move on. Okay, so what we're going to do here is we're going to take a look at the expressions in yellow there. So since the bases are the same, we just add the powers there. So 6 plus 2 is 8, and then this minus sign just tags along like that. So negative 5 to the power of negative 5 to the power of 8 there. Okay, so that's 8e. Let's take a look at 8f now. Okay, so since everything is inside the brackets, that makes things a little bit easier. I have -5 inside the brackets, and then we're just adding 6 plus 2, and 6 plus 2 is going to be 8. One thing that you should get very comfortable with here is if you have a negative sign in the brackets, and if your power is an even number, this is the same thing as just 5 to the power of 8. All right, so you want to be very comfortable with going from here to here, from left to right. So just remember that -5, all in brackets, to an even power is just, the minus sign will just go away. Okay, let's move on to the next one here. And this is a good question here because this kind of follows the idea that I was just talking about in the previous question. If we're dividing by, if we're dividing, let's just put the horizontal line there, and think about this. There's a -10. There's a negative sign inside the bracket, but we have an even power, right? If I have an even power, then that negative sign goes away, and you're just given 10 to the power of 8. And this one's a bit easier because if I look at the green expression here, right, we just look at the powers there, right? So if we're dividing, we subtract the power. So this is the 10 minus the 8. But then this negative sign just tags along, right? And then the final answer is going to be -10 to the power of 2. Good. And that's going to be -100. Okay, so 10 to the power of 2 is 10 times 10, which is 100. Okay, let's move on to question number 9. Write each expression in simplest form without the brackets. Okay, this is a great question because it's testing whether you know how to get rid of the minus sign in the brackets there. Okay, so this first question is not too bad because both the variables are inside the bracket. And if we're dividing, we just subtract the powers, right? So 12 minus 6 is going to be 6. Okay, so the general idea is if you have a negative sign inside the bracket, and if you have an even power, that means your final answer will be positive, so it'll be just x to the power of 6. Okay, so if you think that, once again, I mean, you can just verify this by writing this as a repeated multiplication. I don't want to write out the repeated multiplication for every single problem, but I hope that you can see when you have an even number of negative signs, the final answer is always going to be positive. All right, so the final answer is positive x to the power 6. Okay, let's move on to the next one here, letter B here. So great news, everything is inside of a bracket for now. So I have -a in the brackets to the power 6, all divided by -a to the power of 4. Okay, so what we're going to try to do here is we're going to try to simplify this top expression right there. And once again, if you have a negative sign inside the bracket and you have an even power on the outside, you can rewrite this as just a to the power of 6, and the bottom is just going to be the -a to the power of 4. Okay, so you don't really need the brackets here, but I'll write out the brackets anyways. And then look at the powers here, 6 and 4, right? 6 minus 4 is 2, so it's a to the power of 2, and then you have this minus sign here which tags along. Alright, so the final answer is -a squared there. So I think questions 9a and 9b are very good. And I would say 9c is another good question there. So I have negative p to the power 10 divided by bracket -p all to the power 2. Alright, so we have a negative sign inside the bracket, but we have an even power here, right? So if I simplify the denominator, that's just going to be p to the power of 2. So that negative sign inside the bracket goes away. And then on the numerator, I still have the same expression, which is -p to the power of 10. If I take a look at that and that, 10 minus 2 is going to be 8, so p to the power of 8, and then this minus sign just tags along. Alright, so you got to be very good with dealing with these negative signs here. So question number 9 is really testing to see if you know how to deal with this negative sign inside the brackets there. Alright, I got c to the power of 5 divided by bracket -c all to the power of 2. And once again, there's a negative sign inside the bracket and there's an even power, right? So if you have an even power, that means the negative sign goes away and you have c to the power 2 in the bottom and c to the power 5 on the numerator. So 5 minus 2 is c to the power 3, and there you go. Good. Let's keep on going here. Okay, so now the questions are getting a little bit more tricky here. So negative and then -t to the close bracket to the power 4 divided by bracket negative t close bracket to the power 3. Okay, all right, we have these negative signs, right? Now the problem is we have an even power here, but we have an odd power there. Okay, if we have an odd power, it just means the negative sign tags along. If I have an even power there, it means the negative sign's gone. Okay, but we also have this negative sign right here, so this negative sign tags along like that. Okay, all right, now you can see that there's two negative signs. So a negative expression divided by a negative expression is going to be positive t, and then we have a 4 and a 3. So 4 minus 3 is going to be 1. So my final answer here is just positive t. All right, good. So that's 9E. Okay, let's move on to question number 10 here. The simplified form of this. Okay, great question here. Let's go backwards here. 3 times 2 is going to be 6, so x to the power is 6. And then we have this, 2 to the power 2 is going to be 4. So put that in a bracket there. And then we have the 1 over 36. And then I have a bracket negative 3yx squared, close the bracket. Perfect. Okay, so let's go ahead and see if we can figure out some numbers here. What's 4 times negative 3? Well, 4 times negative 3 is going to be negative 12. And then we have this 1 over 36. So I can put the 36 here on the denominator. And then we'll simplify that on the next step. And then we have x to the power 6 and x to the power 2. So 6 plus 2 is going to be 8. So x to the power of 8. And then I have the single y there. Okay, so so far this is looking pretty good. And now you want to simplify negative 12 divided by 36. So that's going to be a negative 1/3. So you can divide top and bottom by 12. 12 goes into 12 once, and 12 goes in 36 3 times, and then x to the 8, and then the y. All right, so a very good combination question there to kind of finish off some of these homework questions. So very good questions here. Okay, question number 12 here. So we're getting to a few more combination questions here. So I have this expression is written in the form of ax to the power b. So these are all good questions that can appear on a test here. Just making sure you can kind of rewrite these in a different format here. Okay, so let's see if we can blow this up here, and let's go ahead and simplify this. I have a 4 and an 8, so 4 divided by 8 is going to be 1/2, right? And then I have x to the negative 4 and x to the negative 3. So if I think about that, I have x to the negative 4, and then I'm subtracting the negative 3, right? So for dividing, we subtract the powers. All right, this is interesting here because I have two negative signs there. So this is going to be x to the negative 4. And then since there's two negative signs, I'll be positive and then positive 3. And I have the 1/2 in front. And if I keep on simplifying here, I get to 1/2. And then I have the x here. And negative 4 plus 3 is going to be negative 1. Okay, so now I need to write this in the form of x to the b. Okay, perfect. Okay, so if I match up the letters with the numbers here, it looks like a is equal to 1/2, right? So a would equal to 1/2, right? That's what a is. And it looks like b is going to be negative 1. So b equals to negative 1. All right, and then finally the question is, what is a minus b? Okay, so the question is, what is a minus b? Okay, well, the value of a is 1/2. And then we're subtracting the negative 1. Okay, so hopefully that makes sense, right? So we're saying that a is 1/2 and b is negative 1, right? And we are subtracting the expressions there. So if I keep on doing the math here, I have 1/2 here, and if I have two negative signs, I get a plus. So 1/2 plus 1 is the same thing as 1.5, which is the same thing as 3 over 2. All right, so 1 plus 1/2 is 1.5, and that's the same thing as 3 divided by 2, or 1.5. All right, good. Now we have a few more questions to go, and then we're done here. So question number 13, we just give you some polynomials to deal with here. So since we're multiplying a and a, what we're doing is we're just adding the like variables, right? So we're just adding the like variables, right? So if we're adding the x variables together here, like x plus 2x, and then we're just adding the y's and the 3y's, right? So plus y plus 3y. So same idea, but we're not giving you numbers anymore. We're giving you polynomial expressions here. And this should still be a review, right? So x plus 2x, that's like 1x box plus 2x boxes, which is 3x boxes, plus. And then we have a y plus 3y, so we're just adding, right? So 1 plus 3 is going to be 4, so 4y. So a to the power of 3x plus 4y. So same concept, but we're just giving you variables instead of numbers on the powers here. Okay, 13c is a good question here because we're dividing now, right? We're dividing. All right, so I have an a and a, that's my base. So if we're dividing, we just subtract the powers, right? So my numerator power is 3m plus 2, but we're subtracting this from the power on the bottom there, which is m minus 3. Okay, and now we have some rules from polynomial expressions here. So we just distribute the minus sign, which will be negative m plus 3, right? And now we have a little bit more work to do here. So I have 3m minus m, which is 2m, and then plus 5. So a to the power of 2m plus 5. Okay, and one last question to go here, another good combination question here. Let's go ahead and deal with the numerator first. Okay, so since we're multiplying and since the base is the same, which is x, what we're doing is we're just adding the powers here. So I have 2y plus 7, and we're adding the powers, right? So then I add that to 3y plus 2, and then we're dividing this by x to the power of y plus 8. Okay, so let's go ahead and simplify the numerator there. I have 2y and a 3y. So 2y plus 3y is 5y. And then 7 plus 2 is going to be 9. All divided by x to the power of y plus 8. Okay, so what we're doing now, class, is that we're dividing here. And if we're dividing and the bases are the same, you want to subtract the powers, right? So I have the powers of x to the power of 5y plus 9. And because of this division sign here, we are subtracting the power on the denominator, which is y plus 8 in brackets. And as you can see, we've done this a few times already. You just distribute the minus sign there. So I have x to the power of 5y plus 9. And then minus the y minus the 8. Okay, final step here, 5y minus y. All right, so 5 minus 1 is going to be 4y, and then 9 minus 8 is going to be 1. So x to the power of 4y plus 1. All right, so there you go. That concludes this homework video guide. There were a lot of very good questions there, but exponent rules are generally one of the more harder concepts in Math 10, so these are all very good practice questions.